Hello, I'm Megan Van Emmen, Extension Beef Cattle Specialist with Montana State University, and today I'll be discussing interpreting your nutrient analysis you've received back from a commercial laboratory. This information can also be found on our Mont Guide with Montana State University Extension with the SKU number MT 2016-09AG. Forage analysis interpretation is extremely important when developing rations for your livestock. There are several factors we can have analyzed in our analyses, such as dry matter, protein, fiber, energy, RFV or relative feed value, or RFQ or relative feed quality, minerals, nitrates, molds, and mycotoxins. And one thing to keep in mind, having these analyses completed for each load or lot of feed that you have can provide an accurate estimate for what your livestock are taking in and consuming. And it is relatively cheap considered over the entire lot of hay to ensure for that an accurate analysis and interpretation. So the first ingredient we can have analyzed is protein. Labs will include the crude protein number, mostly all basic analyses. Crude protein is just the percent nitrogen in that feed times 6.25. We also have different portions of protein that we can take into account because the crude protein factor includes both non-protein nitrogen and true protein. So the next would be the soluble protein, which is that protein which becomes solubilized as soon as the animal begins to consume the feed. Then we have what we consider degradable protein, which is our rumen degraded protein fraction. Then we have what is known as heat damaged protein, or ADICP, or acid detergent insoluble crude protein, or ADIN, or acid detergent insoluble nitrogen. This typically occurs in those forages that have been baled too wet, which may have occurred in the summer of 2019 here in Montana, where we had a lot of rained-on hay. This could have caused some heating within those bales and rendered some of that protein heat damaged and therefore unavailable to your livestock. Now, one thing to keep in mind, if you did analyze for ADICP, or depending on the lab, ADIN, we only account for this portion if it becomes greater than 10%. And then once we have accounted for ADICP within the crude protein, we have what we consider available protein. The next ingredient we can analyze for is fiber. We have lignin, ADF or acid detergent fiber, NDF, neutral detergent fiber or NFC, non-structural carbohydrates that can be analyzed in a commercial lab. ADF is typically included in all of our basic analyses, and this includes the cellulose and lignin portions of the cell walls. NDF includes the ADF cell wall fractions of cellulose and lignin, as well as the third cellular wall portion of hemicellulose. ADF is directly correlated with digestibility, and NDF is directly correlated with dry matter intake. Now, one thing to keep in mind for the lignin portion is this is determined to be not digestible, and the higher of that number renders a higher fiber portion and therefore reduces the digestibility and intake. We can also analyze for our non-structural carbohydrates, which are our non-cell wall fractions of the fiber portion, which include things like starch. So as I noted previously, NDF is directly correlated with dry matter intake. So as NDF increases, dry matter intake decreases. Similarly with ADF, as the ADF increases in your forage, digestibility decreases. Now the next portion is energy. The main form that we analyze for in our basic analyses is TDN, or total digestible nutrients. And this includes an equation accounting for digestible fiber, protein, lipids, and carbohydrates. However, this is very time consuming as well as costly. So equations were developed to calculate TDN based on our ADF and NDF numbers. This is best used for our forage-based rations. We also have the net energy system, or NE system, which this accounts for the energy losses in digestion. This includes net energy of maintenance, gain, or lactation. This system is used more readily in the dairy industry than in the beef industry. However, feedlots feeding those concentrate-based rations have begun to use the net energy system. Net energy values are calculated based on the TDN of the sample. Some labs will also offer crude fat, or might also be referred to as ether extract, which is just the fat portion of the feed you've submitted. Some labs, though, you will need to ask for that number separately as a separate analysis. We also have the relative feed value, or RFV, and the RFQ, or relative feed quality systems. Now, relative feed value allows for direct comparisons between like forages. So, comparing legume to legume or grass to grass hay. You cannot compare across different forages. RFV is based on the average of 100, which is an alfalfa stand at 100% bloom. And RFV is calculated based on the ADF and NDF portions of the forage. One of the main limitations of the RFV system is that it assumes a constant relationship between NDF and intake and between ADF and digestibility. This is a limitation because you can have two identical forages but have two totally different intakes or digestibilities. The relative feed quality system is a more advanced system than the RFV system because it uses digestibility as well as fiber. RFQ estimates both the forage intake and digestibility and is more accurate in predicting forage value and animal performance. Now, for RFV, it is calculated as the dry matter intake as a percent of body weight multiplied by the digestible dry matter as a percent of dry matter divided by 1.29. So, if we look at our digestible dry matter equation here, this is this first bullet point below the RFV equation. This is a constant equation for digestibility in relation to ADF. And we can calculate RFV ourselves even if we are not provided that number in our analysis. Similar with dry matter intake, we have this set equation for dry matter intake relative to NDF. Now, if we look at the relative feed quality equation, we have our dry matter intake as a percent of body weight, the same as the RFV equation, but this time we're multiplying by TDN as a percent of dry matter and dividing all of that by 1.23. Now, like I said previously, TDN is based off our non-fibrous carbohydrates, crude protein, fat, NDF-N or nitrogen-free NDF, neutral detergent fiber digestibility. Now, we will use the TDN number provided to us by our nutrient analysis. However, if you do have these numbers, you can calculate it yourself. But This is why the RFQ is more advanced, because it not only takes into account your dry matter intake, but also your digestibility portion in your TDN equation. Other analyses include minerals. Many basic analyses will include what we call ash, which is the total mineral content. So for forages, that can average between 3 and 12%, and for concentrates, between 1 and 4%. Excessive values, especially on the forage side, can mean soil contamination. Now, for additional cost, we can have separate analysis for all of our minerals, both macro and micro minerals. However, many of our forage analyses include calcium, phosphorus, potassium, and magnesium within their general analysis. Other analyses we can have conducted are nitrates. This becomes especially important during drought or right after a frost, or during any sort of stress, especially on our small grain forages. You can also contact your local extension agent, and they can potentially test for nitrates as well in your forages prior to sending out to a commercial lab. We can also analyze for mold and yeast counts during our times of increased moisture, especially if we have any rained on forages that we've had to put up wet. However, this does not identify the species of mold present. We worry about the species of mold because certain species will produce what we call mycotoxins. And testing for mycotoxins is rather expensive. And identifying those molds that might be in your hay can help us narrow down which mycotoxins we should be testing for. And we would want to test for mycotoxins because even small concentrations, for example, parts per million or parts per billion, can be toxic to your livestock. So you can send samples to the Scudder Lab at Montana State University, or other commercial labs, and have those mold species identified. And then we can narrow down if we should be doing additional mycotoxin testing. With that, I thank you for listening, and I'm Megan Van Emmen, Extension Beef Cattle Specialist with Montana State University, and I hope you have a great day.